that chapter 1 has the sum and the direct sum. It's a very important concept. Let me first explain about the sum. The context first is that U1 and U2 both are vector space of a subspace of V, right? So that's given, and then we want to define U1 plus U2, right? Subspace plus subspace, that's the definition I would like to give. This is defined as shape of the element vector V plus vector W, all of them coming from V is coming from U1 and W is coming from U2. Okay, subset of the elements of that shape, something plus something, and it's coming from individual part. So this is a subset, right? Obviously subset of what? It's a subset of V, is that right? It's clear. It's not subset of U1, subset of V2, subset of V. Everything came from V. If you add it, you remain inside V because V is closed under addition. It's not clear at this point that why that's going to be a subspace, right? But this is a subspace. That's a theorem, I guess, right? A theorem. If you choose any of this shape, if you add it to itself, close under addition, scalar multiple, close under addition, 0 must be in there, right? Do you think 0 is in there? So what is how do you get the 0? 0 plus 0? 0 is in the U1 because U1 is a subspace and so on. Okay, so I think it's quite easy to check. Some of you can do this in your head. All right, the second idea is this direct sum. This direct sum is denoted like this. U1, O sum U2. If you use LaTeX, this is called O plus and O sum. O plus, that's the command to get this one. All right, but it's denoted like this. As a set, as a subspace, it is exactly this. This one is indicating additional property, right? We write it U1 plus U2 as a O plus U2 if it has a unique representation. Try to kind of sum up in words, but here's a mathematical formulation. Okay, if V plus W, B1 plus W1, and V2 plus W2 in U1 plus U2. Where U1 come from, V1 come from U1, maybe this is not confusing. This should be W2. No, it's a V2, right? So it's a V2 so that it goes with that index. So I'm going to use W1 and W2. V1 came from U1, W1 came from U1. V2 came from U2, W2 came from U2, right? If you happen to have this writing the same element in a two different way, all the elements in here is written in that form, right? Sum of the two elements. If this implies that V1 and W1 is the same, and V2 and W2 is the same. So let's go back. It has a unique representation. There's no way to write an element as a sum of two different ways. That's the property. If this vector space has that property, then we further denote it with a direct sum. And direct sum is good. And that's usually what we stick to. And we need to understand when is this sum is a direct sum and things like that. Make sense? This is our definition we go by, and we're going to see the examples to determine whether this happened or not. So we'll look at example. If you have further question about the direct sum, we'll take that. So here's an example that I thought about. V is collection of all function, not continuous or anything. It's a collection of all function. Right? There's no condition. It's a collection of all functions. And U1 is even function. Since it's described, I hope you understand these as subsets, odd functions. So let's see. These are obviously subsets. Do you think even function is has a 0 in it? Well, geometrically, even function is a graph. It's a symmetry across the vertical axis, y-axis, right? So can you picture 0 function, the graph of a 0 function, which is a flat line on the x-axis, right? So is that symmetric? So 0 is in there. Okay, how about 0 here? Is a 0 odd function. Odd function means what you see in the first quadrant must appear in the third quadrant. What you see in the second quadrant must appear in the fourth quadrant. Right? Yeah. So, but it's in the borderline, so if you think about it, and that is odd function. How about close under addition? Even function. That's something you need to check, right? So let's write down the property of the even function. What is even? What is the algebraic, not the geometric description of the graph? What algebraic property that determines this even function? F of x is equal to f of negative x, remember that? And x here is all the values, right? Not formula-wise. The values here at x is the same as values there. How about here? Odd function. F of x equals, actually f of negative x equals negative f of x. That's odd function. Okay? So if you add 2 of this function, will this be preserved? If you add 2 of this function, will this be preserved? Something to check, right? Not hard, but something definitely needs to be checked. It passes the 3 things. Therefore, it's a vector subspaces of a set of all function going from real numbers to real numbers. Make sense? All right. Then, can you think of this direct sum? Not the direct sum, the sum of these 2 things. Of course, some sort of even function plus some sort of odd function, right? That is absolutely subset or subspace. We already saw that as proposition. If you add these 2 things, it's going to be subspace of that. So any question comes to your mind when you see this statement? U1 plus U2 is going to be mixture of even and odd function. It's a subspace of all the functions. That seems like that's it. That's all we wanted to know at this stage. But it lingers that, is that actually the same? Fair question. I give you an even, all the even function and odd function by just adding them together. Can I reach all the function in the world? What is your gut telling you? I don't know. So here's why. Obviously, it's inside there, right? All we have to do, you pull out an arbitrary function, have to write it as an even function and odd function, right? So that's true. So here's a proof of a statement that is not written down here. What is the statement we're proving? This is actually true, not a question. So f is a function in V, is that right? Period. Arbitrary function. And this technique will simply give it to you. But, you know, well, it's not much is given, so all you can think about is a side note. It doesn't have to be part of a proof. It's about f of x and f inverse of f of negative x, right? That's all we can think about. Can you play with these 2 functions, create an even function? You look at f of x and f inverse of x. Play with this vector addition or something. Can you come up with an even function? So I'm going to call g of x, playing with these 2 things because it's about x and negative x to come up with an even function. The answer was adding these two. I wouldn't expect this is easy. That's once you write it down, you understand why this is even, but it's hard to come up. Let's see. If I plug in x in there, f of x goes there, f of negative x goes. What if I plug in g of negative x? Negative x goes there, right? And that becomes a positive x, right? Isn't that the same thing as the other way around? So we end up the same thing. So you agree this g of x is an even function? Right. How about odd function? What can we do about odd function? Can we play with these two to come up with an odd function? Yeah, if you subtract, you write that down and see if that works. That's hx. H of negative x will be f of negative x. Is h of x. Negative x will be f of x, right? Different order negative must be whole thing negated. So h is odd function, right? So we have constructed an even and odd function out of just nowhere, just, out of just f. Then what are you going to do to retrieve f? What can you do about g and h? Do something about g and h to get f. What if I add this to a function? What happens? These two cancels, right? Becomes 2 times f of x, right? And you divide both sides by 2. That is 1/2 gx, which is an even function, right? 1/2 hx, which is an odd function, altogether becomes whatever you have started with. Algebraically, as is straightforward, but if you just look at the picture, it's very difficult to first answer. The answer is yes. Anything in here is the sum of two things, even and odd function. You know the Fourier series? Any periodic function is written as a sum of a sine and cosine. Sine is an even function or odd function? Odd function, right? Cosine is an even function. And it's saying that anything can be juggling of a sine and cosine kind of fit into this picture. Everything is sum of sine and cosine. It's not equivalent statement. It just kind of fit into this one. All right? That's an examples of a space of functions, right? Not a column vectors. All right. Now we know entire space of function is the sum of even and odd functions, right? Now next question is that I gave you the technique and you found these two things as it works, but you can think of maybe not only this one, maybe there's a different two functions to add up to even and odd, right? So what are that's a direct sum question. What is u plus u2 is a u1 plus u2, uo plus u2, right? Is really the direct sum. So what is the difference between these two and that two? As a vector space, they're the same. And when we write it like this, it had additional property. What was additional property? Unique, right? Unique representation, right? Once you write your f of x in this way, there's no other way of writing it. This is the only way of writing it. That's the unique representation. Okay? If that happens, then we say this is a direct sum. This makes sense, but this doesn't answer whereas out there, different representation, right? Okay. So we need to think about this direct sum, and here's some theorem that I'd like to introduce. It's in the book. That theorem answers it, whether this one is or not. So first I'm going to show you this theorem, and we're going to think about why this theorem is true, and so on. All right. So this is in the book. Let's look at it here. If two subspaces and you look at it, it's a sum. If it is a direct sum or not is completely determined by this property in here. We're already considering a vector space that it is a sum of two subspaces. Don't think this is already answered. We're just looking at two subspaces and it's a sum of two subspaces. And this additional property is equivalent to this thing being the direct sum, right? Make sense? So all you have to do here is that you have to consider, because of that, to conclude this is that, just prove U1 intersection is U2 is containing what element? Zero element. It's a trivial subspace, right? We have done that before with you looking at the column vector spaces, right? So let's see. What is U1? What is the definition of U1? I think it was even function. With even functions there. What is the definition of U2? Odd function, right? And you have to say, if there's a function that's even and odd at the same time, that function must be zero function. That's why we have to show. Okay, so proof goes like this. Take f from U1 and U2 so that f is what? Even and odd, right? And we want to show f of x is identically 0. So this 3 0 symbol means that we're not setting f of x equals 0. No matter what x you plug it in there is identically 0. Just to emphasize, so that I don't have to write for all x in or things like that, right? So how do you show things like this? Techniques of a proof coming in here. Suppose it's not, suppose it's not identically 0, right? So here's proof. Suppose f of x is not identically 0. What does that mean? What logical statement follows there? Hence, if it is not identically 0, what logical? Identically 0 means everything you plug in into 0. What is a negation of this statement? Not everything, right? Everything is negated to something. So there is an element x1, let's say x0, in the real line, right? Such that what? This is not 0. F of x0 is not 0. There's one single element, so it's non-zero. Then it is not identically 0. Make sense? So you have, if you suppose that, we have this existence of f of x0 is in there. It's a non-zero, right? All right, let's use odd property. Odd property. Somebody come up with statement using the odd property. F of x0 is non-zero. So you think of a statement. F of negative x0 is right. What is that? Suppose f negative f of x0, right? What about odd even property? F of negative x0 is f of x0, right? That's even and odd property. So, some conclusion you can draw here? Well, that must be the same f of x negative 0, so that's concluded here. Negative f of x0 is f of negative x0. That is at the same time here, f of x0 there, right? Okay, so negative f of x0 is f of x0, right? You solve for, put in the 2 times f of x0 equals 0. Here we're using the scalar multiple inverse, right? Scalar multiple inverse is divided as 1 times f of x0 is 0. So f of x0 had no choice, but must be 0, right? So what does that prove? What is the C word you write down here usually? Contradiction, right? We started with the existence of number. It contradicts the fact that it's has to be non-zero, right? So what did we show? If you pull out anything in here, just using the property even and odd at the same time, we show that it has to be 0 function. There's no other function that is even and odd at the same time. So according to that proposition here, if you look at intersection being 0 and there's unique representation, it's a direct sum. So you go back in here, answer that question again. We managed to write every function as a sum of even and odd function like that. And here's a description. The question is there a different way of splitting the function an even plus odd function? And the answer is no, because it's a direct sum. Direct sum by its definition, that's the only way, and we prove that using this proposition. Any question? All right, good. So let's look at this statement. U1 and UN, U1 through UN are subspaces. And we write it like this. Whenever you write not sum of two things, whenever you enter sum of many things without the parentheses, and you assume what? Seems like they're ignoring associativity, right? So we're you're supposed to check actually. Doing U1 plus U2, not as numbers, right? As subspaces, right? And the U3 is the same as U1, U2, U3 as the subspaces. These are all the same spaces. Then there's no need to put the parentheses around. You can ignore and write it out. So I guess they checked that. I'm skipping it here. So we have the sum of n things. When is that direct sum? Of course, we started with that, so this is an important part. They're saying only way to write 0 as a sum of u1 plus un is when each individual uj is 0. If each individual element is a 0 plus 0, of course it's a 0. And they're saying that's the only way to write 0, right? So this is the unique representation of what element? 0. If you check just 0, that is sufficient to check all of elements. That's what the proposition says. But the definition is about unique representation of all elements, not just one element. The proposition says unique representation of 0. If you establish that, you're guaranteed that everything else is a unique representation. Okay? So I don't think this is hard, but let's prove that this part is supposed is given. It's about the checking this one. Which direction is easy? If we assume the direct sum, this part is easy, or if you assume part B and proving it's a direct sum, that's easy. Which direction is easy? Number 1 or number 2? Number 1 is if you assume it's a direct sum, we prove 0 has unique representation. Versus if you assume 0 has a unique representation and showing the direct sum, which one's the easy thing to prove? The answer is assuming this one and showing this is unique representation. Why is that? What do we know about direct sum? What is the definition of a direct sum? Definition of a direct sum, it has unique representation for all elements, right? If it has a unique representation for all elements, why not for 0? It's obvious statement, right? Everything has a unique representation of the sum of n things in here. Then of course 0 has a unique representation. What is that unique representation? 0 plus 0 plus 0, right? That's the only thing, because it works. But if you have a unique representation 0, proving the other one will be checking, all right, if I have a non-zero element, and so on, right? Let's try that. Proof of statement B implies the direct sum property. At this point, is there anything that confusing about direct sum? Direct sum is just a sum, but it has additional property. Make sense? So we have that property B, 0 is only one way to represent it, to show it's a direct sum, right? So another thing is that I'm going to show n equals 2 just to simplify, and I'm going to make this one as a hallmark of using induction to, if it is u1 plus u2, then you can go to un using induction. That's a wonderful exercise to do that one. Right now I'm just doing u1 plus u2. And the statement is that if 0 is unique representation. Everything has a unique representation. All right. So it's a direct sum. So I'm going to pull out an arbitrary element. Let v and w came from u1 plus u2 direct sum. We assume it's a direct sum, and hence v is in u1 and w is in a u2, right? That part's given, and this property is a given, and you want to show this as a unique representation. Any technique comes to you when you prove a unique thing? Induction, proof by contradiction, right? So let's say, suppose, what are we supposing? There are two distinct representations. So there's a v plus w and v prime plus w prime, such that v is different from w prime, v prime, or w is different from w prime, right? At least something's different. If they're all same, it's a unique representation. Suppose it had happened, right? And they're coming from u1 and they're coming from u2. Is that right? Only thing we know about the zero representation. Can you pull out the zero statement here by rearranging it? All we know is this property b. We have to use it. It's about representing a zero. Can you write a zero representing a zero statement in here, rearranging it? Collecting v maybe together. Do you see that? Then v minus v prime, is that still in u1? Because u1 is a subspace, they both came from u1. They're just different. How about the second group? W minus w prime is going to be what vector now? Zero vector. We subtracted both of them, right? So this is in v, this is in u1, and this is in u2, right? So what do we know about? 0 is represented by elements in u1 and elements in u2. Then what does part b says? Only way to do it is a 0 plus 0, right? So that v minus v prime must be 0, and w minus w prime is 0 by the property b we're given, right? Does that prove it? It's a contradiction. V is going to be v prime, w is going to be w prime, which contradicts our supposition. Something is going to be different. All right? So that's one statement. And the second statement is 1.9. That so I'm going to make this one as an induction as a homework. But time's up. So I'm going to ask you to actually read the proof of 1.9. It's fairly simple, but I hope you pulled out this type of structure on your own. All right, I'll stop here, and homework will be there soon.